Welcome back to some Quantlab tricks and tips. Today we are going to look at discount functions and how to set your own discount function to mimic your own expectation of central bank meetings and then pricing some bonds off of those expectations. So let's start coding. So first we want to create an object called discount function discfunc in QLang, and we need two of them. We need a base one for which we can put our expectations from central bank meetings, and then we want to create a discount function to use to discount cash flows for the bonds we want to price. And we need a helper function to get to the next Wednesday, since these central bank repo rates are assumed to be 7-day Wednesday to Wednesday rates. So we need to find the next Wednesday from the current date. And then we want to input the data in user control in the Quantlab workspace. So we're going to set the trade date and then what the current rate is, and then how long the curve should be, and the spread to use for the bond pricing. And then also the central bank meeting dates and a move up and down in relation to the current rate. And those are input values. And then we will create vectors of dates to price, for a start date vector and an end date vector. And then we're going to start with a rates vector that we're going to set the current rate just as a constant. We have a for loop in which we will loop through all the forward periods and get these rates into, so we can see if the central bank date is in between any of these periods, and then we will put that rate in starting from the next Wednesday. And at the end of that, we want to place all these rates into a discount function. And in order to do that, we need to loop through all the dates and do some simple compounding using these 7-day rates. So the first one is given. We have 1 through 1 plus the rate to the current end date. And then we have a loop for the rest of the dates in which we compound that discount factor, so that we have 7-day compounding for each loop. And then we have everything we need to create the actual class, the discount function. So we use the function discfunc_interp with the times t and the discount function rates. And we do linear interpolation for these. And then with that, we can also then add some sort of spread that we take in this function and add that on top and create a bond discount function to use for bond pricing. And then we want to show some bonds, so we can then add a function in which we can take in a curve with the number of bonds and then show those bonds' actual maturity, coupon, and the yield from the market. But we can also then use this discount function to get the implied yield for these cash flows for that bond using our newly created discount function from central bank meetings plus the spread. And then we can plot some rates to see what these rates look like in a plot. So then we're done. We compile this F7, and we, as usual, get all the functions that we need. So now we will just grab a workspace, and we need to insert a table. So let's have an input table, and let's attach the input data function. And then let's assume today's trade date, 1.75% rate. And let's see the curve years. So let's make this 30-year curve, and let's assume just zero base spread. And then we can also set how many central bank meeting dates we want. So let's start with 3, and let's set those to something. So let's say that we'll start here with a rate of 50 basis points, and then we'll have another one in November that will also raise with 50 basis points, and then we'll go to next year in March, and let's raise the rates there as well. Well, we should add another one, so let's set this to 4. And we'll do 2024 as well. So let's say that there we have start lowering the rates. So now that's done. So let's also insert a graph to plot the rates, so we can get all the 3 data points. So here we have the data. Good. And then we want our bonds. Insert table, bond pricing, and then let's put the bond pricing table in. And we made it simple so we can use a predefined curve. And again, let's use current date, mid-market rates. And there we have them. So these are Swedish government bonds with the maturities, the coupons, and then the market yield, and then the yield that we created from our CB rates. So we can see that these are a bit high. So let's try to get something that mimics about where we're at. So let's reduce those by 45 basis points, and then let's show those rates. So now we can see that the actual curve that we priced the bonds with is 45 points lower. So we can see that these would be the yields of these bonds, given that this would be the central bank movements of rates from the current level. So this is a very quick and fast way to use Quantlab to get your own market data in and calibrate that using your own spread assumption, and then get an output by just taking I point yield and then using the discount function to get the alternate assumption of what the discount rates for those cash flows of those bonds. Yeah, that's it.